Okay, today's lesson is on exponential growth and decay, and it is the last lesson before we have our test, but it's also going to tie us into and prepare us for the next unit that we have coming after the test. So to begin with, to talk about exponential growth and decay, I want you to think about a question. Would you rather have $1 million today or a penny doubled each day for 30 days? So think about that for a minute, and the answer would be hopefully that you didn't choose $1 million. Because if you look at the table, this tells you the first day you would have a penny, the second day you would have 2 pennies, and then 4 pennies, so forth and so on. And if you look at day 28, you have already over $1 million. And if you went all the way to the 30th day, you would be at $5 million. This is an example of exponential growth. It is growth that happens exponentially very, very fast. And we have two formulas that we are going to deal with to practice exponential growth and decay. So our formulas look like this. Y equals A times the quantity of 1 plus R raised to the exponent. These exponents are X. More oftentimes you'll see T. The ones that I'm going to use later on have a T in them. What you need to remember, and we'll write these down in a minute, that A is your initial amount, R is your growth or decay rate, often a percent, and X is the number of time intervals. And that's something that is going to be different before we talk about interest, but you got to pay attention to what those time periods are. Okay, so here's an example of exponential growth. Suppose your family deposits $5,000 in an account paying 6.5% interest compounded annually on the day you were born. Nothing more was added. Could you buy a car at age 18 with the money in the account? So, to begin with, we have $5,000. That's our starting amount. Our interest rate is 6.5%, but we've talked about how to change that to a decimal. Our time is 18 years because they started when we were born, and at age 18 is when we're going to find out how much money we have. So our equation, if we put those numbers into y equals a times the quantity of r plus 1 raised to the t, is going to look like this. There's your a, 1 plus r raised to the t. You could also go ahead and add those two. So how much money would you have at age 18? $15,533.27. Could you buy a car for that? Absolutely. Might not be the exact kind of car you want, but you can certainly buy a car. Okay, now we have an example of exponential decay, and hopefully you've noticed already the only difference in these formulas is that one is plus and one is minus. Growth plus means we're going up, decay is minus, and that means that you're getting smaller going down. Okay, and one example of decay that is often used is something called half-life, and it is the amount of time it takes for half of the amount of a substance to decay. Scientists and environmentalists worry about such substances because these hazardous materials continue to be dangerous for many years after their disposal. So we're going to start with 100 grams of a dangerous pesticide, and we want to know how many grams will be left after 10 years. So A is my initial amount, that's how much I'm starting with. My rate, it's half-life, so my rate means that half of it goes away each time period. So my R is 0.5, and T is the number of years. So in my equation, I'm going to have y equals, there's my A, 1 minus R to the T. And you can simplify 1 minus R and get 0.5. So how many grams would you have left after 10 years? You would have 0.09766 grams. Okay, now one thing I want to do real quick before we do some more examples is to talk about the difference between the two graphs. And I just want you to be aware of it. If I have this particular one, y equals 1 times 2 to the x. If I put 0 in, and you can check my math, you put 0 in, you're going to get 1. If I put 1 in, I'm going to get 2. 2, okay, you can put these in your calculator. you're going to get 4, and 3, you're going to get 8, and 4, you're going to get 16. Okay, so if I go plot those points, at 0 I have 1, at 1 I have 2, at 2 I have 4, at 3 I have 8, and at 4 I have 16. So if I were to connect those as if I had the points in between, you can see, and I'm doing a pretty bad job of connecting the dots, but you got the idea, that this is not a straight, it's not a line, it is a curve. And hopefully you can tell from that that this is growth. Missed that box, not decay. Now, what if I look at the next one, the next example that we have, 15 times 0.5 to the x. If I put in 0, anything to 0 is 1, so I'm going to have 15. And if I put in 1, I'm going to get 7.5. If I put in 2, I'm going to get 3.75. If I put in 3, I'm going to get 1.875. And if I put in 4, I'm going to get 0.9375. So hopefully you can see, well, we'll just go ahead and plot it. At 0, I started with 15. At 1, I had 7.5. At 2, I had 3.75. At 3, I had 1.875. At 4, I had 0.9375. So if I take those points and connect them, you can see that I don't do a good job of connecting points, but also that it's going to keep going down and that this is an example of decay. All right, so I want to go in and fill in our note sheet, and I need to pause. Okay, so the note sheet that we have, okay, so to continue, we have two IXL topics that we're going to work on today in class. The first one is from Algebra 1, x.1, and that's making sure you know how to put these types of problems, exponents and parentheses and such in your calculator. And then you're going to have problems x.3 that deal with these word problems of exponential growth and decay. So as I just mentioned, we have two types of formulas. We have one that is growth and one that is decay. And the important thing to look at is if it's growth, when you read the problem, it will be a plus, and if it's decay, then it will be minus. So the formulas are pretty much exactly the same, except for that one sign. So let's again write down so you'll have it as a reference what you need to know about what goes where in the formula. A is what we call the wrong thing there, the initial amount, and the initial is the amount that you start with. That's the beginning, okay? Um, R is your rate, okay? That's actually let me go back and add the word growth to that. Let's call it growth or decay rate. And the important thing to remember is it has to be a decimal or a fraction when you put it in your problems. You can't leave it as a percent. Okay, the T stands for time periods. These are general problems of exponential growth and decay. Later on, we're going to talk about interest problems. But when you're discussing exponential growth and decay, those time periods, you've got to pay attention to the problem because it might be days, it might be months, it might be hours, it might be seconds. You just have to read the problem and figure out what the time period is according to the problem. And y, of course, is your final amount or the amount that you end up with. Okay, so the start to the end. All right, so I'm going to do 3 examples and then I'm going to let you go get started. So, how much of a radioactive kind of bismuth will be left after 6 minutes if you start with 80 grams and the half-life is 2 minutes? Okay, so here's an example as we just talked about. Your half-life is telling you that R is 1/2 or zero point 0.5, whichever one you prefer. Okay, this is how much I start with, so that's my A. And then I have my time periods. And if the half-life is 2 minutes, you've got to figure out how many 2 minutes are in 6 minutes. And hopefully y'all can figure out that there are 3 2-minute periods in 6 minutes. So that gives our T equal to 3. So my formula, half-life means it's decaying, so it's 1 minus R to the T. And Y equals A is 80. 1 minus, we'll go with the decimal, and T is 3. Okay, we've practiced a lot. Put that in your calculator just like that. Pause if you want to, see if you can do it correctly before you see the answer, which is 10 grams. Okay, look at the next one. Oliver has $40 in a savings account. Okay, $40, that's the beginning amount. The interest rate is 10%. That's as a decimal would be 0.1, 0.10, compounded annually to the nearest cent. How much will he have in 3 years? So this is straightforward. T equals 3. Hopefully you can understand that I'm getting money, so this is an example of growth. So when you do this, if you will write down this formula each time you do the problem and then plug in the numbers just like this, it will be easy to figure out if you make a mistake where that mistake is. It will also help you memorize that formula. So when you put that in your calculator, you will get, pause if you want to, check yourself, $53.24. Okay, and the last one, another half-life's a little different. Okay, how much of a radioactive kind of scandium will be left after 8 hours if you start with 72 grams and the half-life is 4 hours? So again, my half-life, R equals 0.5. A is my 72 hours. That's how much I started with. They're asking me how much is going to be left. And after 8 hours, but the half-life is 4 hours. So how many 4 hours are in 8 hours? That gives you 8 divided by 4 is 2, so your time is going to be 2. So half-life means I'm decaying, so I'm going to subtract my interest rate. And Y equals 72 was A, 1 minus R is 0.5, and T is 2. So plug that in your calculator, pause if you want to, start back up, and you'll get an answer of 18 grams. So make sure you know how to use your individual calculator when you do these problems, and if you have any questions, please come see me.